In this video, I'm going to introduce you to the cross product. But before I do, let me just give you a quick reminder. Suppose you have vector A, and remember we've already done this, and vector B. If you compute the determinant, then it will give you this thing here. Well, this thing here will be a number. It won't be a vector, it will be a number. Well, this number here is equal to the area of this parallelogram. And then we also extended it to 3D. So in 3D, suppose you have three vectors, A, B, C. So you've got your vector A, vector B, and vector C. If you compute the determinant of this, then it will give you a number. Well, that number. So this whole thing here will be a number. It won't be a vector. It will be a number. Well, this number here is equal to the volume of this parallelepiped. And we've done this. So now I'm going to introduce you to the cross product. But before I do, look at this. This is a number, this is a number, and this is a number. So this will be a number, a number, a number. All these will be numbers. So the point is that this is a number, this is going to be a number, this is going to be a number because it's a component of the vector, and the components are always numbers. So these will be numbers. So now to introduce you to the cross product. So here's a cross product. The cross product, let's say you've got a vector written in this form and another vector written in this form. Well, with the cross product, you have this unit vector, and unit vector, and then this will be your components of vector u, and then components of vector v. So when you look at this, this is a vector, number, and so on. If you look back up here, all these are numbers. All these are numbers. But then down here, these are vectors. So when you think of I, you've got to imagine this. You've got to imagine x-axis, y-axis, and your z-axis. So when you think of this thing I here, I hat, is a unit vector. So in your mind, you've got to think about this vector here, and this vector here will be 1, 0, 0. So when you think of this, you've got to think of this arrow here. And when you think of J, it will be this in the y direction, and it's of length 1. So when you think of J, think of this arrow in your mind, and then it will be 0, 1, 0. And when you think about this k hat, it will be this unit vector. In your mind, visualize this small arrow here, and it will be 0, 0, 1. So the point is that this is a vector, this is a vector, this is a vector. Compute the determinant of this. It will give you this whole thing here, and then this thing here will be a number, but then this is a vector. This thing here will be a number, because remember the determinant will be this times this, and then take away this times this. But the point is that we've done this before. So this whole thing here will be a number. This whole thing here will be a number. This thing here will be a number, and then you've got your. Well, you see this. Well, this whole thing here will be a vector. Up here, hang on. Up here, this whole thing here is a scalar. This whole thing here is a scalar, is a number. But then down here, when you have these vectors here, unit vectors here, this whole thing here will be a vector. But here's a weird thing. This vector here is this thing here, this vector here. So when you compute what's called the cross product, when you compute this thing here, and remember, at the moment you have no idea what this cross product even means. At the moment, I'm just asking you to accept that the cross product of u and v will be you performing this. It will be you looking at this I, and then discard the horizontal, discard the vertical, and looking at this, and then J, you would look at J, and remember it's going to be plus, minus. This minus is important, very important. And then this is a plus. So when you do this, it would be J, discard the horizontal, discard the vertical, and then you would look at this. That's this bit. And then you would look at K. Discard the horizontal, discard the vertical, and then just look at this, which is this bit here. the point is that you have no idea what it means to have one vector crossing another. So u cross v, it would then just give you this whole thing here. Well, this whole thing here is a vector, and this whole thing here, this vector here, is this purple vector here, and this purple vector here, this purple vector here will be perpendicular to the plane of the parallelogram of the other two vectors. So the other two vectors will form a plane. It will form a plane like a sheet of paper. Well, this vector here will come out of the sheet of paper, and it will always be perpendicular to the plane. Meaning this the vector here, the purple vector here, this thing here, the purple vector here will be 90 degrees to the u vector, and it will also be 90 degrees to the v vector. And the other thing is whether, going back to here, remember at the moment you have no idea what it means to have one vector crossing another. Bear with me. So when you have u cross v, it will give you this whole thing here. This whole thing here will be a vector. This vector here will be this purple vector here, and this purple vector here is always perpendicular to the plane of the parallelogram here. And then also the magnitude of this vector here, is equal to the area of this parallelogram. So there's a lot to take in, and remember the most important part of this video is really that you realize that you don't fully understand why this thing works. You don't fully understand why this vector here, why the magnitude of this vector here equals the area of this parallelogram, and why it's perpendicular to the other two vectors. So at the moment, just accept that that's true. You are currently here at the moment. As you learn more and more and more, when you get to linear algebra, then you will have a better understanding of what's going on here, and then you can go back to here and then try and understand what's going on. But there's a lot to learn along the way. So for the time being, just accept that when you have one vector crossing another, it really boils down to you computing this whole thing here, and this whole thing here is your vector here, and then this vector here, the magnitude of this will equal the area of this, and then it's always perpendicular to the other two vectors. Okay, so at the moment, just accept that it works, and realize that you don't fully understand why it works. Just accept that when you do this, it will then give you this. Okay.